the first one is just x is 600
Okay.
and y is 120. So if you do y over x, then you'll have tan theta.
Okay.
So if you do inverse tan y over x, then you should get t theta.
Y over x. 120 over 600, is it?
Mm-hmm.
Is that a fifth?
Yeah.
And did you get an answer?
Yeah. Does it matter if it's in degrees or radians?
Let's go with degrees.
Oh. 11.3.
I'll take your word for it. I think I'm in radians. Degrees. 11.3 degrees. Okay. B.
Oh, so B is just x is 50 cos theta. No, wait, 50 cos 11.3.
50 cos 11.3.
T. Yeah, and T. And then Y is 50 sine 11.3.
T sine.
T. Yeah.
Find the parametric equations for the plane's motion. So that's equals x, that's equal y. Okay.
So C is just 97.97 meters.
So let's say 98.0. And what was that one? C. After 10 seconds, was that 50 sine 11.3 times
Yeah,
times 10?
10.
Okay. Okay.
I think you would like substitute one into the other.
How would you do that?
But I'm not. That's right. I'm not sure.
I'm not sure either. Let's see. What did you mean by sub one into the other?
Like, you know, when you're finding like the Cartesian equation,
Yeah.
like that.
Um, if I was to, so this was probably totally wrong. But let's just call that 1. Let's call that 2. I'm going to do 2 divided by 1. So 50 divided by 50 is 1. Sine divided by cos is tan 11.3. T divided by 3. And then you have y over x. And so y equals tan 11.3 x.
How does that show it's a straight line?
What if I wrote it as instead of tan 11.3, I wrote that
Oh,
as
close mx plus c.
yeah, y equals 0.2 x, y equals mx plus c. It's basically it's linear.
Mm-hmm.
Linear equation. X is linear, maybe. X is linear, therefore straight line. And E.
I don't get E.
Sorry, I should say Y is linear. Oh, I don't even know. E. Explain why the domain of t is greater than 0 is not realistic. Because it includes very large numbers. Like it includes, you know, a million, a billion, a trillion.
Okay.
But a plane cannot increase its height forever.
Oh, okay.
So at some point, this will kind of make sense, this straight line. But eventually it'll reach like the upper limits of the Earth's atmosphere and it'll, you know, it's not a rocket ship or something. However you'd say that. Okay, let's see this one. So angle of elevation is 11.3 degrees. 50 cos 11.3 t. So they actually boils that down to 49.0. That one, same thing. The sine t, it was 98.1. Is that what you said?
I think it's 98.0.
Okay. They're saying 98.1. Who do I trust? I think that this number here, they did that to 5 sig fig for their working out for this one. Is that what they did? So just, yeah, keep your previous stuff to 5 sig fig and then round this one to 3 sig fig. D. Y equals 0.2x, which is what we said. Linear equation. Since this is a linear equation, the motion of the plane is a straight line with a gradient of 0.2. Yep. And then AT is greater than 0 is not realistic, as this would mean the plane would continue climbing forever at the same speed and with the same angle of elevation. Alright. If you have to comment on a modeling assumption, consider whether the assumption is realistic given the context of the question. Yeah. Alright, any questions here?
No.
I think you're mostly good for that. Oh, here we go. Right, what does this do?
Okay, so K is like the upper limit, so you have to find when the stone hits the ground.
Okay.
So you just have to solve the like y equals the quadratic equation and find when t is equal to 0. Not t, sorry, like the whole equation.
So it's when it's y is equal to 0?
Yeah. T is equal to 2.83. And K also.
And that's what k is?
Yeah.
Okay.
I think for the second one, you just substitute 2.83 into like the x equation.
Go on, try it.
Ten meters.
10 meters. Okay. Something tells me none of this is correct.
Oh.
There's no way it was this easy. Let's see. Initial speed of 5 at an angle 45 can be described using the following parametric equations. So something tells me this is suvat. You've got an S of 25, you've got a U of 5, this type of stuff going on. K is a constant, so the time is between 0 and K. Oh, excuse me. So a stone is thrown from the top of a 25-meter high cliff. Initial speed of 5. That is position after t seconds. So x is its x coordinate. Y is its y coordinate. Where x is the horizontal distance from the point of projection. Y is the vertical distance from the ground. Yeah. Maybe it is. So when y is 0, you should get a positive and negative number. And you
Yeah.
gave me the positive one?
Yeah. Obviously, time can't be negative.
And so you got 2.83, was it?
Yeah.
So, all right. And then you just sub that in there. Maybe it is that easy. Nope. Not even close. So it's saying it's 2.648.
I used my calculator.
Minus 4.9. Fraction 5 root 2 fraction 2 25 2.648.
I don't know what happened. But you know the 5 root 2 over 2 on my calculator is showing as 5. I don't know why, even though I typed in 5 root 2.
Hang on. So the way I did it was 5 root 2 close bracket. Yeah.
I didn't put brackets. So.
Yeah,
Yep.
you
Still
didn't close the bracket.
showing as 5. I don't know why.
So close the bracket.
I put brackets, but it's still showing as 5.
So press fraction. Are you using graphical?
Yeah.
Fraction 2.
Yeah, I put it in exactly like that, but it's showing 5. I have no clue why.
Let's do it a different way. 5 divide by 2 times by root 2.
Oh yeah, no, it's working.
Okay.
Yeah, 2.65 or 648.
And I'm just going to leave that to 5 sig fig because maybe we need it. So find the value of k. So that's when that hits the ground. And then you... Okay, so try subbing that in.
9.36.
9.36. 9.36. Yeah, so, turns out it was that easy. All right. Any questions about that?
No.
Here we go. Ice skater.
So the first one is just putting t equals 0 into the equations.
Mm-hmm.
So x would just be 8 cos 20, which is
what is 20 times? What is
it would be because t is 0, so it would just be 0.
Yep. Nope. What is cos 0?
1.
Mm-hmm.
Oh, so 8. X is equal to 8.
Yep.
And then y is equal to 6 root 3. Oh,
6.
wait. That's not right. Minus 6 root 3.
Negative 6 root 3. The motion of figures say relative to a fixed origin. Aha. So their x coordinate is 8 and their y coordinate is negative 6 root 3. So it looks like it's here.
Mm-hmm.
That's the start. Okay. Maybe that's wrong. B.
Wouldn't that wouldn't be just be that point at like -4, 0?
Looks like -4, 0.
Yeah,
I'm guessing -4, 0. And I'm sleeping
I
well at night.
calculate that.
It is when these two must be equal to each other, I think.
Oh yeah. Okay.
This is because we skipped that section on intersecting parametrics or something. Okay, we make these two equal to each other. It's when the x and the y is the same. Is that right?
So 8 cos 20, but the x and the y aren't the same.
No, they're not. But the time is the same? Is that right?
But isn't the time always the same in both of them?
No, the time won't be the same.
That would.
The x coordinate would have to be the same as itself.
What?
So 8 cos 20 t would have to be equal to 8 cos 20 some other t. Like, I don't know, s or something. That's not
going to work.
Maybe it will.
Wouldn't you just get t is equal to s?
Let me have my fantasies. Yeah, you'd get t is equal to s. Oh, we shouldn't have skipped that section. How else? Let's think. So what does... So it has the same coordinates as the other thing. It's... So
I
it
mean,
has the same?
To 0, I think.
No. Hold on.
So you could find
So
something.
we're doing it just by looking at it. Maybe that's what you're supposed to do. Maybe you're supposed to just do it graphically.
I don't know.
I like my method. Basically, it's when the x coordinate is same as... It's the same x coordinate twice.
Yeah.
But different times. It's the same y coordinate twice, but with different times. 12 sine t minus pi over 3 equals 12 sine 10s minus pi over 3. And is there something we can possibly do, or does it just boil down to t equals s both times? T shouldn't be equal to s though. No, that doesn't work. Let's take a look. Oh, it looks like it was probably a big deal, was it? B. From the diagram. Yeah, so you just get it from the diagram. -4, 0.
I mean, it looks like they had a method.
They just made the y equal to 0.
Oh,
So from
okay.
the diagram, the figure skater intersects his own path on the x-axis, i.e. when y is 0. So
Okay.
they just let y be equal to 0. They solved for
You
t.
don't need to solve anything.
So the maybe a different question. You'd let y be equal to 0. You would solve for t, and then you would sub that answer in there, and you would get x. But they'd have to give you y or x to begin with. So, all right. We just didn't have enough information. C.
So that's when x is 0 in part C.
Yeah, there you go. Okay. Now you'll get the practice.
So 8 cos 20 t is equal to 0. I think.
Yep.
So then you divide by 8.
Sure.
So 0 equals cos 20t. And then you do 0 divided by cos 20. Wouldn't you just get t is equal to 0?
How do you get rid of cosine?
Oh, you arc cos.
Yep.
So you'd have pi over 2 is equal to 20t.
Was arc cos 0 pi over 2?
Yeah, in radians.
Why are you in radians? Oh, it's in radians.
It's in radians, I think. I mean, there's a pi, so.
Arc cos of 0. Yeah, pi over 2. There you go. Okay.
And then so t is equal to pi over 40. And then you substitute that in the y equation.
Mm-hmm.
So 12 minus 3.11.
For the coordinates, minus 3.11.
Minus 3.1. But there's another one, like down there, like between minus 10 and minus 12.
Yeah. Because it repeats. So you could do that plus, or you could get a second answer, it might give you that one. You could get a third answer, it would give you that one. You could get a fourth answer.
Wouldn't the one between 2 and 4 just be 3.11 positive? Wouldn't it just be the same?
So that one's up there. Hang on,
Yeah.
find the coordinates where the path crosses the y-axis. Hang on. Crosses the y-axis.
Yeah, that's what we did.
So that's when x is 0. And find the coordinates of the path where the fixator intersects his own path. Yeah, find the coordinates of the point where the path of the... So you have to find all of them, I suppose.
Yeah, but I don't know how to find the second one.
How do you get your second answer with pi? With sine?
You add 360.
That will be your third answer, but okay.
Oh, okay.
And 360 degrees in radians?
2 pi.
Yep.
So do you do minus 3.11 plus 2 pi?
Yep.
That's 3.17.
Okay.
I don't understand. Wouldn't it be the same? Like, wouldn't it? Why would it not be just positive 3.11?
That would be cosine. Cosine graph is symmetrical.
But it's symmetrical, the graph.
The sine graph is asymmetrical. About
the sine graph, the motion graph.
Doesn't look symmetrical to me.
Okay. I just thought it would be the same.
So based on appearance, it might look symmetrical, but we calculated it. So minus 3.11 and 3.17, they're close, but they're not.
Okay. How do you find the other answers?
The way you find your second answer...
180?
Yep. 180, what do you do with 180?
Add.
That's for tan.
Minus.
Yep. And what is 180 in radians?
Pi over 2.
Yep.
Wait, no. Wouldn't it just be pi?
Yeah, pi, sorry.
Minus 6.3. That's wrong. Because I got minus 6.3, but that's obviously wrong. Because on the graph, it's like next to minus 12.
What did you put into your calculator?
Minus 3.11 minus pi.
2 minus 3 is not the same as 3 minus 2. It should be pi minus first answer.
Well, pi minus 3.11.
Very good.
6.25, which is also wrong.
Okay.
You're not at 6.
Should be it. Let's see. We did sine. Your first answer looks like it's all right. You're certain about your first answer?
I think so.
Hang on. Because the first answer, 12 sine. The first answer wasn't obtained by doing arc sine. It was just by substitution. So maybe that's why. Maybe we have to go back to the cosine thing. So let's see. So it's when the time is pi over 40. It's when time is pi over 40, but then the time has to change. So time has to change. So go back to the cosine one. It's when 0 is equal to 8 cos 20t. We got our first answer was time equals pi over 40.
Mm-hmm.
At what other time does it cross?
I don't know.
How do you get second answer for cosine?
Add 180.
That's tan.
No, 360.
What do you do with 360?
Add
360 minus first answer. So t was equal to pi over 40, was it?
Mm-hmm.
And so t will also be equal to 2 pi minus pi over 40, because that one we got with inverse cos. Yeah.
Which is 79 pi over 40.
79 pi over 40?
Yeah.
Looks good to me. So let's see.
Shouldn't there be 4 then?
There should be 4. How can you get 2 more?
No clue. On the negative version?
When time is negative?
Oh yeah, time would never be negative. I don't know.
How did you get your additional answer for sine?
Add 2 pi?
Yes.
Okay. So do like pi over 40 plus 2 pi?
Yeah.
(81 over 40 pi?
So that's the time of the first crossover. That's the time of the second crossover. That's the time of the third crossover.
Um, 79 pi over 40 plus 2 pi is 159 pi over 40.
Okay, and so...
And then now you just put them into the y one to find the coordinates. So with pi over 40, it's minus 3.11. And then with 79, with 79 pi, it's minus 11.59.
Minus 11.59.
And then with 81, it's minus 3.11 again with 81 over 40, which doesn't look right. And then 159 is minus 11.59 again.
It's cosine,
Mm-hmm.
so it is symmetrical.
Okay, so the other one is 3.11 and 11.59.
So I think so. And I think as well it has something to do with the transformation of the graph.
I hate
Where
transformations.
I think you would have to do, we were given where the y-axis, that's when x is 0. I just want to check something here. It's when x is 0. And so we have 0 equals, we divide by 8 cos 20t. Yes. So I get 1 is equal to, sorry. Pi over 2 was equal to 20t, was it?
Mm-hmm.
And that we have to keep in a bracket, I believe. We would get all of our other answers for cosine, and then we would divide them all by 20. So we would say 20t is equal to negative pi over 2, positive pi over 2, and then 2 pi minus a half a pi would be 1.5 pi, so 3 over 2 pi. Minus 3 over 2 pi. And then we divide all of those by 20. Do we end up with the same thing? Minus pi over 40, which was our first one. Positive pi over 40. This one is 3 pi over 40 minus 3 pi over 40. Try subbing in 3 pi over 40.
In where?
In
Why?
y.
$11.59.
So that's the positive one.
Yeah.
So yeah, so that's how you get the positive ones. It's to do with trig, how you kind of keep this bit in a bracket until the very end. So you do arc cos both sides,
Mm-hmm.
and because it's a transformation, stretch t direction scale factor 1 over 20, and so you get all of your answers first.
Okay, yeah.
It's because usually with a trig graph, with a cos graph, you would do 360 minus. In this case, we would have to do 360 divided by 20 minus.
Okay.
Or just do it the normal way and at the very end divide everything by 20. And D.
I don't know how to do D.
Determine how long it takes the figure skater to complete one complete figure of 8 motion. Well, let's see. It's when their coordinates go back to being the same again. It would also be like one full turn of the circle if you were doing cosine and sine.
So you know the point that's minus 4, 0?
Mm-hmm.
Couldn't you just do 8 cos 20t is equal to minus 4 and then just solve for t?
Yeah, that'll do.
Okay.
8 cos 20t is equal to what, sorry?
Minus 4.
That should work.
And then I got pi over 30.
Right.
I didn't like do other answers yet. My other answer was pi over 24.
Pi over 24. I think the answer might be pi over 12 or something. Let me tell you why. How often do they go through the point minus 40?
Twice.
They go through it twice every rotation. Let's try a different point. Their initial point for part A, you said was 8 minus 6 root 3?
Yeah.
So let's use that.
So 8. Wouldn't it be t equals 0 or t equals pi over 10? That's what I got.
Or t equals, what was it?
Pi over 10.
And how did you get pi over 10?
Because the other solution would be plus 360.
Let's see, pi over 10. And let's just see, so I'd keep that. So 2 pi minus 0 is 2 pi. Is also equal to 20t. And so t would be equal to 2 pi over 20. So that's pi over 10.
Mm-hmm.
I think that's it. I think it's pi over 10. Let us see the answers. 2 pi over 10. Why is that? Let's see. The period of this thing is 2 pi over 20.
Yeah.
So the skater returns to his X position after 2. Oh. Yeah, are we correct?
Yeah.
Okay. Let's see. What was the other stuff we were saying? 11.59, 3.11, and...
Wait, no, for D, the answer was something different.
Okay, so C is all correct. The period of this thing. Okay, so we said the skater returns to his X position pi over 10 minutes later.
Mm-hmm.
The skater returns to... Oh! That's sneaky. Do you know what it is?
No.
So this is the starting position.
Mm-hmm.
What we calculated was this thing here. So you just have to double it whatever way you do it. You just have to double your answer whatever way you do it. So it's 2 pi over 10 or pi over 5.
How do you know that you have to double it?
How
do you know that you calculated that?
Just trying to think of it in terms of trig. Let me see. So trig graph. We were doing, what was it? Cosine. So we wanted, like, when does it go? So it starts here. When does it go back to its original? But it doesn't necessarily. So if I was to do this thing, yes. So if I was to say it's there, and that's the first one, what we were kind of finding was this one, because that's when it goes back, but actually we should have found that one.
Okay.
So what we found was like half of their rotation, but you have to so I thought it's the same as this one. Hang on. So from the start, they go through that point once, twice. If they're going, let's say, up, left. So once, twice. Yeah, so whatever way you do it, you just have to double it. Because of the time. So it takes them half the time to get there. Yep. There you go. Any questions about that?
Not really. It's a bit confusing, but
yeah,
it's not that bad.
Sure is. Let's see. Okay, exam question. Wow. Let's try this.
I have no clue how to do it.
I think it will be this x coordinate.
Yeah.
This x coordinate, something like that.
Yeah, but I don't know. Oh wait, it says minus pi over 2 to pi over 2.
Time.
Yeah.
Ah, I see what you're saying. Those are the start times and the end times?
Yeah. So you just have to find the x coordinate at those and then subtract.
And yeah, I think so.
15. So the one for minus pi over 2 is 3.73.
3.73.
Yeah.
And so.
And the one for pi over 2 is minus 3.73.
That's
right.
Looks right.
Wait, no, just do 3.73 minus 3.73.
Yeah, and it'd be better if you used answer getting like 5 sig fig. It's basically answer times 2.
7.45.
7.45 centimeters.
Yeah.
Okay. B.
What does it mean by find the radius?
Radius from the center to the circumference.
Okay.
The vase is filled with water up to the level of the x-axis. Find the radius of the vase at the surface. Yeah, so you have a 3D vase, and so you're just finding the radius of the kind of 2D circle. If it was a surface, it's to do with a rotation. Volume of solid of rotation.
I don't know.
Revolution.
What that is.
So imagine this was a 3D vase.
Mm-hmm.
And you were to spin it around. This red line would be like a disc. It would make a circle.
Mm-hmm.
And that's what they're talking about. So it would be the length of this line.
How do you find it?
How could you find this x coordinate?
Y is equal to 0.
I believe so.
But wouldn't like that whole line be y is equal to 0? So how would you know?
Y is equal to 0 only at that point and at that point. The graph is this black line here.
Oh, okay. at it. T is equal to pi over 3. So it's just pi over 3 is the radius.
Is the radius the time?
Yes.
Amogha.
Because this one isn't time.
So the y coordinate, when the y coordinate is 0, that's when the time is pi over 3.
Yeah.
We want the x coordinate.
Oh, okay. Minus 8.9.
Minus 8.9. So I believe that's what it's given us there. It's given us this coordinate is minus 8.9.
So that's 8.9.
So the radius is 8.9 centimeters. Okay. Is it 8.90 3 sig fig?
8.86.
8.86 centimeters. Okay, and C.
So I think for that one you have to find like when x is equal to 0.
Correct.
Yay. Okay. How do you solve 18t is equal to 32 sine t?
When x is 0, 18t minus 32 sine t equals 0. See, you kids, you work hard. I don't work hard. I just put in 18 x minus 32 sine x, but might not work because trig gives multiple answers and all that. Shift solve. I'm going with lucky 7. Yeah, why would you do that to me? See, nah, 7 wasn't lucky. Let's get lucky. 999. Why? Maybe is there only one answer and it's 0? No. Sign repeats, doesn't it?
Yeah, of course.
Shift. Solve. Minus 999. Alright. Looks like I have to work. 18 times t minus, let's see, we could divide everything. 9t minus 16 sine t equals 0. Both square numbers.
So,
Given that the cross of the steepest point, find the depth of the water at this point. So we have to get the... Oh yeah, that's one way to do it. That's one way to do it. Seems difficult though. Seems difficult.
wait. Yeah, okay, never mind.
So one way is we could let... It's when x is 0, so we could find t. 18...
But when you just have 9t is equal to 16 sine t, but I don't know how to solve that.
So you would 9t is equal to 16 sine t.
Right. I have no clue how to solve that.
Um,
Would you divide by 16 and then do like arc sine? Would that work?
but you've got a t on both sides, so
Yeah.
usually you'd factorize.
Not factorized.
Let me try some magic. Let's see. Why didn't calculator work? I bet that graphical calculator would work. One thing you
Yeah.
could.
Yeah. Oh, I think I found solver. X is equal to 9.42 according to my graphical calculator.
I'm happy with that. So time is 9.42. Sub that into y.
But why would you have cos 9.42? That's not going to work.
In radians?
Oh, it does. Okay. 23.999, so 24, I guess.
Oh, so 24?
Yeah.
Is it minus 24?
No, no, it's
Oh, we would just say the depth is 24 centimeters.
yeah.
Right, let's see.
Nope.
8 centimeters. So it was a third of that for some reason. Let's check. 7.45 is correct. B, where is B? B was 17.7.
What do we do for B? Where
Uh,
is B?
I think this was B, was it?
Yes. That's not what we got.
Did we have to get an extra one? I didn't realize I don't have the. Let me.
8.86 is half of 17.7. So we somehow got half the answer.
Yeah. Remember we got minus 8.9.
Yeah.
And then we said, oh, well, it's 8.9. But you would have to double the time for it to get around there. Maybe that's why it is.
I have no clue.
This tricky thing. So let me do the thing. So I brought these onto. So sine t was 18 over 32 t. So sine t squared. Sine squared t would be that. You'd square both sides. Y minus 8 over minus 16. Minus 8 over minus 16 is equal to cos t. Is that okay? Y minus 8 over minus 16 is equal to cos t.
How? Oh, it's rearranged. Yeah.
Yeah. And so cos squared t is equal to that. If we were to...
Maybe that squared.
Is equal to that squared. If we were to add these two together... we still have t though. Let's see. Well, what do... We get 18 over 32 t all squared plus y minus 8 over minus 16 all squared is equal to 1, because sine squared t plus cos squared t is equal to 1. And then we'd have to do something with that. This... I don't know. That's because we still have a mixture of t and y. Let's see, where did we... So find the width of the opening of the vase. The vase is filled up with water to the level of the x-axis. Yeah, find the radius of the vase at the surface of the water. So we said it was... How did we get this one? 8.9. That's when y is 0. When y is 0, we got time. but we had to double it or something. We got time. Why would they do this? 'Cause it's a vase. It's not changing over time or anything. Why? Hang on. So for some reason, B, we had to double our answer. And C was we had to divide it by 3.
Mm-hmm.
I'm going to have to look at that. Given that the cross-section of the vase crosses the y-axis at its deepest point, so that's the only one. Find the depth of the water. The depth of the water. So it's when y is 0, t is a certain thing. No. When x is 0, t is a certain thing. And then when t is 0, that should work. Let me just take a quick look. Oh, this is very similar. This one has worked solutions. So let me just see this one. Parametric. Find the length of the opening. Given the cross-section of the ball crosses the y-axis at the deepest point. So let's see. So this is for B. Sub t equals pi over 2 into 2. T equals pi over 2 at its deepest point into x is that, y is that, x is that, y is that. So they subbed the maximum for time into y.
Mm-hmm.
How
So
is
would that be like the end and not in the middle?
into 2? So y is that. So you get 1. Y is a minimum when time is 0.
Mm-hmm.
So they doubled their one as well. Y is a minimum.
Wouldn't it be when x is 0 and not t is 0?
Y is at its lowest when x is 0. Yeah, I think so. They're saying it's when it's at its maximum time. Pi over 2. So if you sub pi over 2 into y, you get 8. You get 8 minus 0, which is 8. But why is it when time?
Yeah, why is it over 2?
Don't know. It's so weird that they're mixing time with a vase. That's like with the figure skater, I could kind of get it, but
might not be time. It might be something else. I don't know.
It's just a parameter, yeah. All right. Anyway, what do you give yourself for this stuff?
Like a half.
Yeah, I'll send these to you anyway, and you can send me any questions you might have. Any questions for me in general?
No.
All right. Well done, Amogha. You did great. I look forward to chatting again next week.
Bye.
Have a good week. Goodbye.